All right, I want you to consider an implication, P implies Q again. There's a little bit of vocabulary I want to introduce here. If you have a conditional statement or an implication like this, if P then Q, then its converse is the proposition Q implies P. So, with respect to this original proposition, if you reverse the implication to go the other direction from Q towards P, that is called the converse. So that's one vocab word I want you to know, converse. Now, there's a couple others as well. We can also talk about its inverse. So with regards to the P implies Q, we have converse, and then the inverse is something else. That is not P implies not Q. So it's like negation of the hypothesis implies the negation of the conclusion. That's called the inverse. And then there's one more, the contrapositive. The contrapositive is not Q implies not P. So essentially, it's like the converse of the inverse, right? Like you take the inverse of the original implication to get not P implies not Q, and then you flip that arrow to go the other direction, not Q implies not P. That's a converse of the inverse, is called the contrapositive of the original implication. So these are basically different ways of rearranging that implication. They're all different. Technically, initially we should consider these as all different propositions. I want to make very clear that none of these are a negation. All right, none of these are actually the negation of the original implication. These are just different ways of reframing, not reframing, just sort of like different statements related to the original one, right? The converse of the original one, the inverse of the original one, and the contrapositive of the original one. So, to better understand these three things, I want you to do an exercise. I want you to make a truth table for all of these. So, go ahead and get started now. You can pause this video and do that. I am also going to make the truth table so you can check yours. So I'm going to show you the sort of structure of the truth table that I have in mind. You have your inputs P and Q. We're going to write all the possible combinations there for those, and then we'll have the original implication. We'll make a column for that. We've seen this one a couple times already. Then we will make a column for the converse. Q implies P. Now, for the inverse and the contrapositive, those involve negations of P and Q individually. So I think it is helpful to make columns in your truth table for the individual pieces that you're putting together. So I would make a column for not P and a column for not Q, right? Which is just going to be the negations of these two columns. And then put those columns together in one direction or the other, implication in one direction or the other, to produce the inverse and the contrapositive. Okay, so let's go ahead and get started. First, I'm going to write all the combinations of P and Q in lexicographic order. You may have seen already, there's kind of a nice format to doing this. You go true, true, false, false, and then you alternate true, false, true, false. And that produces all the combinations in nice alphabetical ordering. Now, implication. So true implies true is true, right? But if you have a P is true, so a true hypothesis, but a false conclusion, that is the only case, that is the only row in which the implication would be false. For a false P, you're going to have vacuous truth both times, right? So that, just a review, we've done that a couple times now, but that's what how implication works. So now converse, we got to think about the arrow going the other direction. So true implies true is true. False implies true is going to be vacuously true. True implies false is going to be false, and then false implies false is also vacuously true. So there we go. So let's kind of highlight where the falses are with red. This might be a good idea. I should have been doing this all along. Sorry. And go back to your truth tables and highlight the falses in red or something like that, just to make it really clear. Okay, so now for the negation, we're going to do false, false, true, true. There's the negation of P. So it's just the exact opposite values for P. Now, it has to correspond to over here, so we have to make sure that this is in the correct order according to this. Right, so it's the exact opposite of P, and now we'll do the exact opposite of Q. It's going to be false, true, false, true. There we go. And now we can start combining these columns using implication in one order or the other. So for inverse, not P, which is this column, implies not Q. So the first row here is going to be false implies false, which is vacuously true. Then we have false implies true, which is still vacuously true. Then we have true implies false. That's going to be false. And true implies true, which will be true. So we'll put this here. That's our false. Our only false situation is in that row. And then finally the contrapositive. Not Q implies not P. So we're going this column back to this column. So false implies false is vacuously true. True implies false is going to be false. That's the one situation where the implication is false. True implies false. Then we have false implies true is vacuously true, and true implies true is just true because it's just true. So where's our false? It's right here. All right, pause for a second. Oh, well, check your work, pause for a second and take a look. What do you notice? Here's what you should notice. These are the same, and these are the same. So, in fact, what we have shown here by truth table is that an implication and its contrapositive are actually equivalent to one another. This is called the contrapositive equivalence. And it is that P implies Q is equivalent to not Q implies not P. So hypothesis implies conclusion is equivalent to the negation of the conclusion implies the negation of the hypothesis. So you notice here you have to get the contrapositive, you have to negate both of them and also swap the order. So the arrow is going in the other direction. That produces an equivalent proposition. And that's going to be pretty useful to us down the line. Now, the fact that the converse and the inverse are also the same, that is basically the same exact relationship. Because the inverse, you'll notice, is the contrapositive of the converse. So I don't really need to state that as like a separate special rule. I'm just going to state this one equivalence here, and we could apply that to get the other one if we want to. So there we go. I think this is the end of section 1.1. What I'm going to do next is actually skip ahead to 1.3 and discuss more logical equivalences, and then we'll get to 1.2 after that.